Okay. So I kinda need you to. Did you send me a paper? You have, Okay. Do you know the kind of like the average score, or anything like that? Okay. Okay. Oh, this one. Okay. Um, do you need me to go through? Okay. Which ones do you need me to go through? Because we can then pinpoint which ones you need. Hello. Mm-hmm. Question six. Sorry, sorry. This one. Okay. Hang on. I just realized one thing. I don't have my drawing pad connected. Just connect it now. Okay. Um, Hang on. This one here is it? Okay. So it's speed time, right? Speed time. Um, oh, the answer is A. They have the same instantaneous acceleration at time t1. Yeah. Um, like if I ask you to check whether this statement is true, how would you check it? Like what would you do to try to check it? Mm. No. Okay. So if I ask you to check whether acceleration is the same from a speed time graph, you would have to draw the tangent. Do you see that? So if you were to draw the tangent, you'll realize that at t1, right, at this point in time, that's when the slope is similar to this slope. Yeah. So in a way, that's why A is the answer, right? Let's try to figure out why the rest are not correct. Okay. Um. So how do we explain to someone that the runners do not have the same acceleration at time t2? How do we explain that? Yes. So the tangent at runner 2 for t2, the gradient is not the same as runner 1's gradient. Right? So you see runner 1's gradient is kind of like this, right? Yeah. So the gradient is not the same. Therefore, B is wrong. Okay. All right. Then let's see statement 3. Why is statement 3 wrong? Okay. So statement 3 says runner 1 is overtaking runner 2 at t equals 2. Okay. So kind of like, okay, so that's wrong, right? That's wrong. Why? Because if you look at the first part of the race, that means if you look at this time, right? Do you see this time here? Okay. From the start to the time, right? Do you notice that runner 2 has, hang on, right? The distance traveled by runner 2, do you notice that it's this entire area here? Yep. Okay. So what you notice is that by T2, runner 2 has already gained some like speed ahead of same some distance, right? Some distance ahead of runner one, and that was the distance. You see that, right? This is the distance. So that means runner two has like this amount of speed, right? Sorry, distance. Sorry, not speed. Distance ahead of runner one. Like runner two is ahead of runner one. Okay. Yeah. Um, but then at T2, right? It doesn't mean that runner one is overtaking runner two, right? Because by T2, runner two is already like in front. You see, if I were to draw for you, right? Let's say they were starting from here. Let's say this is one and this two, right? But runner two is ahead, right? Is ahead by this amount of area, right? This distance. So at T2, right? At T2, runner two is ahead of runner one by that amount of distance. So this amount of distance here, right, is the area like expressed here. You understand that? Hmm. So now the problem is, right? The problem is um what like what happen what's gonna happen next. So what is happening next? So let's look at what happens after T2. After T2, runner one has a greater speed, right, than runner two. So the speed of runner one is kind of like this much now, and the speed of runner two is like this much now. So you can see that runner one is now faster than runner two. And in fact, okay, and in fact, the area, right? I mean the area, the difference here. You see this area here? Okay, that will be the like the distance that runner one, right, is able to run, right, more than runner two. Okay, but you see this area must make up for this green area. You understand? Because you see, right, this is the number two, runner two's like distance ahead, right? Runner one must cover that distance, right? Must close this gap. So this orange area must be equals to the green area. Then we can say runner one has overtaken runner two, right? When you want to overtake someone, you must meet the person at the same place at the same time. So he must have covered that extra distance, right? You know, at the second part here, right? So he must have covered like after, but that is like after, like after T2. You get that? Okay, yeah. Okay, good. Then the last one is the last statement is wrong. Like runner two is decelerating, but why is it wrong? Mm-mm. Becoming slower. Yeah. So that's the way you describe it, right? Because you describe it as the acceleration is decreasing, okay, but it means that it's still accelerating. So runner two is experiencing decreasing acceleration. You get it? Okay, cool. So that's for number six. Right, that's done. Next one, do you need to do number seven? Ooh, okay, can. All right. Um, but you see, right, I'm a bit concerned about the lack of. What do you think I would have told you to do if you're trying to solve this question? Hmm. So why is it not drawn? Speed time graph, initial speed 5 meters per second, uniform deceleration, comes to rest in 3 meters. Then I ask you how long does it take, the time taken. Can or not now? Oh, but with drawing the graph, does it make it a lot more clearer now? Yeah, it's the area under the graph. Okay, can So always remember. Yeah, you see, right? That's the thing that I was trying to always like harp on right at the start because I said kinematics, kinematics, kinematics. Always draw graph, always draw graph, always draw graph. Right. Anyway, number 7. Next one. You want me to go through? I think 10. I think I have to explain 10. Do you need me to explain 10? Yeah, I think I have to explain 10. 10 is hard. 10 is hard. I mean, I can recognize a hard question when I see one, so I know 10 is hard. Okay? Hey, 7 wasn't hard, huh? Okay, 10 is hard. Right, so for 10, right, you have to I have to illustrate this thing for you. Okay. So the stone falls, right? So do you see me drawing this thing like it's just almost touching the ground. Okay? Alright. What do you think the speed is? Like, can you give me a speed? What do you think the speed of the stone is? Just before here. 3 meters per second. Okay? 3 meters per second. 3 is a bit short though. Okay, let's go with 30 meters per second. No, but here's the thing. Um 30 meters per second. How long was the stone falling for? Like how long was it falling for to get 30 meters per second? 3 seconds, good. So I mean it's falling lah. Okay. And then in a very, very short time, almost immediately, right? This stone comes to complete rest, right? Comes to complete rest. So it means this stone comes to a complete stop, like this, right? Then the 0 meters per second. So the question is here, right? In this region here. Hang on, sorry. Okay. Hmm. Sorry, huh? Hmm. Okay, never mind. So in this like spot here, that means I don't care about the top part anymore. I really care about this part here. Okay, I have to do this step by step. Okay, what's the acceleration like? What's the deceleration like? Sorry, for the stone. It'll be like a equals to v minus u over t, right? And v is 0 minus 30 over. What do you think a short time means? Like like comes to rest almost immediately. What do you think? Like how fast do you think that is? There must be a time frame, but it's not immediate. Yeah, it's not 100% immediate. Yeah, no, it's fine. 0.5 seconds. So how much is that acceleration there? What is the resultant force? Let's say the stone is 1 kilogram. Resultant force will be 1 times 60 newtons, right? 60 newtons. Okay. So the resultant force will be 60 newtons, correct? The stone experiences a resultant force of 60 newtons. Agree? Not done yet. That's why I say this question is hard. Because I'm not done yet. Okay. So in terms of forces, we need to draw the forces acting on the stone. Right, so let me draw the forces acting on the stone. So the resultant force, this is a resultant force. Resultant force is what? Is it a real force? Is resultant force a real force? No, right? A resultant force is the result of other forces. So when the stone hit the ground, right, what are the forces experienced by the stone? There's a normal contact force, right? I'm going to erase that one because I'm only talking about the part when, right? Do you see the normal contact force here? Okay, versus the weight, right? Versus the weight of the stone, right? I mean, the stone has weight, right? Okay, mg, right? I need you to understand that these are the only two forces acting on the stone upon impact. There's no air resistance. Air resistance was acting on it, like, before it hit the ground, right? Anyway, you don't even need to care whether or not there's air resistance. We just need to know that at impact here, the normal contact force is way bigger than the mg force. Hang on, and that is different for when you put the stone on the ground. Let's say you put a stone on the ground like that, right? Do you agree that the normal contact force will be equals to the weight? Okay, but when it's just but when it's being dropped and it has an initial velocity and it impacts the ground for a very very short moment, the normal contact force is much bigger than the weight, right? Why is that so? Like, why does that happen? Okay, no, it's okay. I'm asking you. I'm asking why, but I'll explain why. But you have to remember that that's the language that you should be thinking in terms of. Okay, why is there a difference? Is because this stone is moving and it needs to stop. It needs to decelerate to zero. Okay, so where's the velocity pointing? Where's the initial velocity pointing? This one, downwards, right? Okay, what's the final velocity? The final velocity is zero, right? So while this stone is coming to rest, where should the acceleration point? Good, it should point upwards. So that's the reason why, okay? That's the reason why that in order for the stone to stop, right? Or in order for this stone to come to rest, right? It must experience an acceleration at that very, very short amount of time, but the acceleration must be upwards, okay? And therefore, because of acceleration, when we say acceleration, we think of resultant force, right? Therefore, for that very, very short amount of time, the resultant force must also be pointing upwards. But in order to get an upwards resultant force, the normal contact force must be bigger than the mg just for that very, very short amount of time. It's just to slow the stone down. You understand? Okay. Then we have to write. I know this is a very, that I already told you already, this one is a very convoluted question, right? I don't even know whether the teachers talked about it or anything like that. Okay. Then we say that n minus mg is the F net during impact. Do you see that? N minus mg equals F net during impact. Yeah? And then and then the worst part about it is now we have to find N force. So what is the N force? It will be F net plus mg. Correct? And how much is that? 70 newtons. Yeah, 70 newtons, right? So therefore, right? Okay. But this normal contact force, right? Do you see this normal contact force? Like, um, this normal contact force, 70 newtons, is by what on what? By ground on stone. Correct? And therefore, the question is asking, what is the direction and size of force acting on the ground? So that's just the action reaction pair of this. So N prime, which is 70 newtons, is the force by the stone on the ground. Right? And therefore we see the option and see which one is the answer. So it's B because it's downwards and larger than the weight of the stone, right? We know the weight of the stone is like 10 newtons, right? I mean it's 10 newtons, right? 10 newtons. If it's at rest, it's supposed to be like 10 and 10, right? But now because it needs to stop, the normal contact force, but again for a very short amount of time. After it has completely stopped moving already, it will go back to 10. But for the very short amount of time, the normal contact force, bam, on the ground, right, is 70 newtons. Okay? And that's why the answer is B. You understand, huh? Okay, you taken out all these already? Yeah. So this is the to I mean 10 is a very good question. It's just that it's it's a lot of steps to explain. Yeah. Yeah. So that's why the normal contact force is larger than the weight of the stone. And furthermore, it's like it's somewhat there's like a Newton's third law layer. There's a layer of Newton's third law, and then there is like, you know, talking about like uh the resultant force and normal contact force and all that. That's why this question is when I saw it, I was like, phew, okay, yeah, there's a lot of steps to this thing. All right, next question you want to check in with me on? 11? No, fine. Okay. Um I think the first thing you need to take note of is this answer here. Sorry, this part of the question here, that key phrase there. Center of mass is at C, right? This one here. What does this mean? Okay. What does it mean? I mean, it's moments, right? So moments is everything and anything to do with forces, right? So what does this mean? Weight is acting. Weight is a force. So it's acting from C, right? So this mg, right? Okay. So what happens now is that you have displaced this card to the side like that, right? Where you can see that the center of gravity is not directly below P. I mean, if it's not moving, right? If you didn't displace it, then it probably looks something like this. Sorry, I know I'm massacring it, but like it will be like center of gravity should be directly below. Then it will just hang very nicely like this, right? But because I moved it, right, I rotated it, I pushed it to the side, so therefore it's rotated to the side now. Okay, so the weight therefore is no longer, I mean, in a way, the weight is no longer passing through the pivot. Do you see that? And if it's not passing through the pivot, then it will create moments, right? Because once I let go, right, then it will start to swing back. And if it swings back, then the weight here will generate a moment around pivot P, correct? Okay. So then the question is, so how much moments is that? That's what they're asking, like, how much moments is this you know, that due to the weight. So you need to find this distance, right? Because that's the perpendicular distance from the line of action to the pivot, right? You see that that's the distance there, right? Which is how much? 0.3 meters, right? 0.3 meters. Yeah. So then the moment that that causes the laminar to swing, right? How much moment is that? That is the weight mg times 0.3 meters. So it's mg times 0.3 meters. Okay. Mg is 2, so 2 times 0.3, and therefore it's 0.6 Newton meter. And it's a type of clockwise moments because it's going to swing there, right? So clockwise. Yes, you got it now. Huh? Yeah. So yeah, I mean let's answer this one here. They I mean hang on, I'm just wondering now. Did your teacher go through the paper even? Oh, okay. So at least I'm going through MCQ. Okay, fine, cool. This one number 12. Oh, jump to 26. Okay. This one. Ayo. Wow, this one's a very annoying question. Ayo, it's so annoying. This question is so annoying. Okay, this one's an annoying question. Okay? Okay. Right, look very carefully, They're saying how is the heat, anyway, not energy, how is heat transferred through, okay? Okay? Through the aluminum pan, not the water. They're asking you how is it transferred through the aluminum pan? Like, that's it. I don't need you to talk about how the convection currents in the water form and then it starts boiling or anything like that. No, they're just asking you how does heat transfer through the aluminum pan? That means how does heat transfer through a metal? Okay? And then they ask you and through the plastic handle. Again, they're not asking you like anything like nothing to do with the water at all or convection currents or anything like that. So it's basically just straight away just heat going through the aluminum and heat going through the plastic handle. So it's just two different metals, two different solids. One is a metal, one is a non-metal, but both of them conduction. Hey, walao, you, hey, metal is movement of free electrons and the vibrational atoms got both. Why you choose only one? Okay, cannot. You know where you went wrong? Okay, okay, good, good. Next one. This one. Wow, your light is still. Yeah, I see you're working here, right? Then I ask you, then what's the point of them telling you this? What's the point of them, like, them giving you this info here? For what? They tell you the speed of light in air and speed of light in prism is this. What's the point of giving you speed? Refractive index. Did you find it? Sorry. You said n equals to 1.2. So did you find it? So n is equals to 3 over 2.5, right? Let me double check. My math not good one. So 3 divided by 2.5. Yeah, 1.2. Yeah, you got it. Okay. And then you went to do. Okay. So you actually okay. That means you got somewhere. So I'm not very concerned now. You did do correctly. Sine inverse of 1 over 1.2. Sine inverse of 1 divided by 1.2. 56.4. Okay, this is correct also. Okay. And then, so you know your TIR. Yes, your TIR. Eh, hello. If it's TIR, it's reflection. If this is 58 degrees, then the other angle is also 58. Why you draw straight down? You went to choose A. You chose straight down like this, right? If you chose straight down like this, what's this angle anyway? Ah yeah, that means you calculated everything already. That means you were right everything eh. Your angles are damn bad. This angle, this is not 58. Can you tell what angle it is? Actually, you can, right? I think 90 minus 58 is not. I mean, you chose this, right? This is a 90 degree. It's 90 minus 58. It's not 58. This is not 58. You did everything correct. Ayo, you is B's answer. Oh no. Because in your mind you're always thinking, right? You see the thing go like that, right? So you think that it's always like this, right? Correct or not? Okay. But then hey, didn't any of the students complain that there's something wrong with this question? Do you hear the students complain, say like, hey, the question got fault leh? Do you notice anything wrong here? I mean, I'm seeing it. I'm pretty sure I know there's something very majorly wrong here. You don't see it? I'm going to ask the teacher, I'm going to void this question. Whole level void the question. Let me show you where's wrong, okay? What's wrong? You look at this angle. You tell me what's the angle there. You tell me what's this angle here. Or is it 35? Oh, right. They made a boo boo lah. They draw one straight line like this, right? They draw one straight line like that. But then they didn't realize that by drawing a straight line, right, people would see the triangle here. Some people would think there's 35 there, and some people would think there's 32 because of 90 minus 30. So which one is it? Right? Something wrong. There's something wrong with this question. Ask the teacher and avoid the question. This one is confirm question got problem. Okay? What they should have done, right? What they should have done is not be lazy, right? And just don't draw the outside lah. Just don't draw the outside here. Don't draw the outside here and just draw something else. Inside here, just draw another light ray that doesn't look like horizontal one. Like this. Okay, then just draw one light ray that really does look like it's like 58. Something like that. Like just uh, something like this. Then this would be correct. Understand? Yeah, they should have done that. Yeah, these people. Okay, but there is an error in the question Okay, 29 done. 30 What actually that means you get it correct already. Okay, come 30. Aiyo. Okay. This one here is really one of the classic trick questions, right? I mean, if you do enough practice, you will encounter this question. But if you didn't, then you didn't encounter. But yeah, lah, this one here, if you get it wrong, I can understand. But previous one is no go. Previous one was okay. This one here, I just want to tell you that. Okay, you see these two light rays, G and H. Okay, let's talk about G and H. G and H is coming from where? Where is it coming from? Yeah, that's right. G and H are coming from an object that's at infinity, far far away, right? Okay, okay. So let's just focus on G and H first. What do you understand about where the image is if the object is at infinity? Object at infinity. No, it's at the focal point. You ask you to memorize the lens diagram. That's why I said. That's why. Okay, at least that part there you should know. If you can tell me that it at the focal, you have to know that. Okay, so that one is I know even though I say the question is difficult, but you have to know that. So let me just remind you again. It's over here. Okay, right. So telescope, object infinity. If you had drawn all the diagrams, right? When I shown you the diagram, you would have formed an image that was here. You see that? You would have formed an image here, like this. Okay. Then I would have told you that the telescope image property is inverted real at f. Correct? Yeah. So the image would have been at f. It would have been here, right? The image would have been here. This would have been the image, which means that A is f. Does it make sense now? So when this light ray P, which is parallel to the principal axis, once it hits, okay, so you must understand, ray P, right, is coming from somewhere else. It's not coming from the same object. It's coming from totally something else. Okay, they're just asking you for this other random light ray, where would it go, right? So you know that it will cut at F, right? But the image is formed at F here, so that means that this light ray will cut at A, like that. Understand? Now, okay, you must remember the lens diagrams, I know it was the start of the year for you. The lesson, the light and lenses was the start of the year for you. I will be teaching light and lenses again with the main class because the main class will have to do light and lenses anyway, right? You understand? Okay, but when you attend for those lessons, right? You it's gonna be like a lot of repeats, so you just take note of it. But anyway, next year exam is gonna test you on light and lenses again, right? So yeah, and okay, okay, all right. Then how about the paper two? Yes. Oh, you see? Oh, look at that. A smiley face, someone. No, look at that. Yeah. Finally, yes. I know vector diagrams are a pain, right? So I can see corrections. I can see corrections. Is there anything that you're still not sure of, even though you have done corrections? I'm okay to go through it. It's fine with me. Oh no, which one? This one. Okay, stop, read back. Do you see this? Do you see that they're trying to be tricky here? Actually, why such a big emphasis on light and lenses? I don't understand. You're IP, right? You're going on to A levels, right? Yeah. Why is there such a big deal about? Do you know? Do they not realize that there's no light in A levels? Like the emphasis of the A levels is waves. Like waves is such a problematic. Like I every year I teach my A level students, right? Waves is always a problematic chapter for all of them, leh. And then yet in secondary school they always downplay the waves. It's like they say, oh, light is very important, light and lenses. But then you go to A levels and it's like light and lenses is not. There's nothing tested, like nothing at all. Unless a new syllabus has light and lenses. You know that you're gonna have a new A level syllabus, right? Hmm. I don't know how different it is. No idea yet. Or maybe the syllabus is already. Have to check. But anyway, do you see what's wrong with this angle? Are you supposed to use this angle? No, you're not supposed to use this angle. right? You're supposed to use the angle to the normal. You understand it? Wait, what? Is that the mistake you made? Oh man. Yeah lah, see that's the problem. See? You calculated the angle, but then you missed out the fact that they wanted this angle here to the surface. So actually, right, like from the two examples I've noticed so far, right? Your problem is not the physics part. Your problem is angles. You have bad geometry. You're bad at geometry. Is it the same for your E math? Do you have problems with angles? Like, for those kind of like triangle in a circle question? No, don't have ah. Walao, then you label physics only you cannot do. The worst thing is that you're doing all the physics things correctly. You did all the physics things correctly, you see? But then you gave the wrong angle. That's all. I mean, angle to the normal. Every time we calculate, it's angle to the normal, right? Don't be too irrationally afraid of light. You actually got it all right, man. You just wow. No, no, no. I didn't realize the teacher is so particular about this. Wow. Hmm. Okay. Hey, hello. What's this? What's this? What's this? 11.25. What's this? Huh? Who asked you to put 4SF1? Huh? Okay, never mind. Yeah, go on. Hey, lazy, this teacher. 4 marks. Huh? Throw one whole explanation question 4 marks. Give more questions, ah. Why throw one whole thing 4 marks like that? This is called lazy, the teacher. This one? Oh man. Oh, we done so many times already, right? This one. Yeah. Okay. Doesn't matter. Right. We solve it again. Can? But we use the exact same methods. Okay, is that the only one? Or you got some more? The rest are okay. You figured it out already. Okay, can. Okay. Right. So we do it the same way I've been doing it, Can? Right. And I hope you understand that I mean, not to be so pig-headed and say that, oh, my way is the only way, but my suggested way is usually the more standardized way of being able to solve any of these moments question if you do it step by step. Okay. Step one, which one's the most important object? Yeah, the plank is the most important object. Good. Right? So the plank is the most important object. Let me just mark out the plank. So we have to draw all the forces acting on the plank, which actually has been drawn for us already. Okay? So we got the normal contact force here, X. We got the normal contact force, Y. We got the weight of the man pointing downwards like this, and we got the weight of the plank, which we don't know exactly where it is, right? It's somewhere. It's just not in the middle, right? It could be here, it could be on the left side, it could be on the right side. Okay, we have no idea. Can? That's the problem, right? Okay. So not knowing where the weight is, right, is one thing. So what's the next step? The next step is that we got two pivots, right? So what should we do? No, we got two pivots. We choose one to be the pivot. Yeah, we choose one. Okay. So do you want X or do you want Y to be the pivot? And based on your choice, right? That's where you will be able to find or not be able to find the weight of the plank. That's I think that was a problem. Which pivot did you choose? I'm assuming you chose something. Did you choose anything? You didn't choose anything. Oh, Okay, you didn't choose anything. But I had a standard procedure, right? I mean, does this not sound familiar to you, the standard procedure? It sounds familiar. Okay, if it sounds familiar, that's great. That means your long-term memory is not that bad. Okay, but let's choose a pivot. Okay, since we are at this step now, let's choose a pivot. Do you want X or do you want Y to be the pivot? Okay, I mean obviously you done corrections, and I can see that they say by taking, huh? By taking moments about point X. That's not right. Wait, you mean your teacher corrections say taking about point X, man? That's not right. That's not right. Why is that? That's not right. Hmm? Hmm? We are okay. Why? Why? Okay, I find it a bit strange. Eh. No, no lah, no. You should take it at point Y. Okay, let me explain why. Okay, you already know the normal contact force here, right? You already know the weight of the man. You also know the weight of the plank, right? Okay, so basically you know all three forces, right? Do you know what's the weight of the Y? What's the force of Y? Okay, so you're saying that we can find the difference, right? Basically, 2000 plus 650 minus 1000. Yeah, right. The two downwards minus away. Okay, can so you're saying okay, but what if it didn't occur to you? Because that didn't occur to me at first, right? I just thought Y is just unknown, you know? Yeah, I just thought Y is just unknown. You know what? If I don't know Y, then I'll make the pivot at Y. Okay, yeah, this is my pivot. Part of the reason why I'm showing you this, right? Part of the reason why I'm doing it like that is also to show you that it can be done either way. It can be done by taking pivot at X. It also can be done by taking pivot at Y. I'm just showing you the other version. You understand? Okay, yeah? Okay. So if you do take pivot at Y, what sort of moments is X? What sort of moment is the weight of the man? What sort of moments is the weight of the plank, wherever it is? Because wherever it is, right, it's on the left side of the pivot, right? So it's going to be anti-clockwise, right? Okay. So then we do ACW equals to CW, right? About pivot Y, right? Then we do ACW equals CW. So what's the sum of the anti-clockwise moments? How about the man? Man is what, 650, right? 650 times what's the distance? 3.5, and then plus. Okay, so the thing is that we don't know what's the distance, right, of the weight, right, of the plank to the pivot. So I'm just gonna keep it as 2000 times x. Can? And that's the sum of the two anti-clockwise, and then I equate it to the sum of the clockwise. You see the clockwise, which is 1000 times 5. Do you see that? 1000 times 5, and then you find x. But that will be the distance of the weight from pivot y. What do they want though? They want you to oh, from x lah. Okay lah, then yeah lah. I mean that's the reason why your teacher went to find from point x lah. But I'm just showing you that no, it doesn't matter which where you take pivot from. If it wasn't immediately clear to you that y is the difference of the forces, and you don't know why, you just put the pivot at y and you find the moments around the pivot. You get x, and then you take the 5 meters minus away the x. That will be the distance from x to the center of mass. Yeah. If you walk towards the pivot, the force on that pivot will increase. You this 1 mark, 1 mark, 1 mark, all give away one. Hey, so honestly, how much do you get in total for this whole paper? In percent 60 what 67%. How many careless mistakes? Aiyo. Actually, I got a feeling right as I'm going through all the questions that I just said, right? You probably realize that oh shit, you should have gotten it, you should have gotten it, you should have gotten it. Right or not? I mean, I got a feeling that your aptitude is, I mean, even though I can't really get it out of communication from you, but I can sense that you actually understand a lot of the things on it. Why why you still making those like okay? So I got a weird sense as to like okay, like for example, kinematics, draw graph, never draw, right? Then this light question, right? Uh, object infinity, image at f. I've said it quite a few times already. And then the what I mean, and then that question on the moments question. There's like a standard procedure to solving those kind of questions. So I have a feeling that you might be overthinking the difficulty of the questions. Like you feel as if like you can't be using those basic steps to solve this question because this question seems a bit more difficult than normal. I don't know. I that's my just my guess, right? And because of that, therefore, I think you don't dare to use the basic procedures to start solving the questions, and therefore you get nowhere, right? Like you get stuck somewhere, and then you just try to do it on your own. But if you did the normal steps that we always use, I got a feeling that you should be able to get much higher than this, lah. To be honest. Yes. Okay. Okay. Right. But it's okay. I the way I see, I see all your workings and all that. I honestly think is you have your foundation is very strong. You just either you overthink or you're careless. I think you overthink a bit. I got feeling you overthink a lot. Yeah, I see this thing here. I see the working here and all that. I got feeling you overthink quite a bit. But it's okay. Now at least you just need to settle at the right frequency, right? Don't go too high. Don't think it's too difficult. It's really not that difficult. I mean, I'm saying that for you. I'm not saying it in general. I mean, I feel it shouldn't be that difficult for you. So don't think that I'm just saying it for the sake of saying it. I mean, this is just my personal like impression. Okay, well, I mean, honestly speaking, I'm quite happy with the way you have done the rest of the paper. I'm just looking at it now. Yeah, the ones that you got correct and all that, I mean, it just shows that you have a lot of. I mean, even the ones that you got wrong, um, it's careless, yes, and then yeah, it's not gibberish lah. Your wrong, your mistakes are not gibberish. So I'm okay. Yeah. Okay. When does school end for you? Yeah, this Friday. Mm-mm. No, I'm just telling you that probably no lessons all the way until next year already. Oh, what me? Uh-huh. And then yeah, lor, no time already. Yeah, lah. It's okay lah. Then let's not do it. But I might ask you to come in last 2 weeks of December for that for thermal properties, right? Because I've taught it to the main class already. Have I taught it to you yet? Not yet, right? Oh, I was. You were. Oh shit. Next, Next time remind me. Please remind me. Because sometimes I blur one, no. Then you sit in for okay. It's okay. Then don't need, then don't need. Then you just but the next one will be January will be light lah, light lessons. Yeah. But okay lah, you just sit in lah, huh? Okay, because your light still very shaky. Okay. Okay lah, can lah. Okay lah. How's the rest of the subjects? Physics the worst ah. What happened to the other subjects? Oh no. I mean, just I mean, out of genuine curiosity, like what happened to Chem? Okay, Chem is how much? Okay, 76 is very good already lah. Wow. Compared to my physics, 67% already. How about math though? No, wait, what do you mean by it's one of the better ones? But this okay, so you got to understand the context of it. So your sec three, sec four is more or less the finals already, right, for your secondary school life. Um, they are naturally going to be a bit more harder than sec two, for example. Okay, I'll tell you what I feel about your paper here. Your this paper, right? Mm. Did your teacher tell you anything about this paper? Like, did he say that this is a difficult paper or easy paper? Did he tell you what kind of paper it was? No, these are all O level questions. Almost all, almost all O level questions. He picked out all the difficult ones. Like I can tell, like you see all these, right? These okay, straight up, all these question one O level, question two also O level. Even this runner thing is also O level. The stillborn one is O level. This car and mass, all these are O level questions. Even the font and the format also looks very O level. So these are all O level, but he picked out all the difficult ones. You know what I mean? He didn't give you the easier O level. He just chose the more challenging ones. Like, I mean, that's what I see lah, right? And I find it very strange though that he did that because if you're gonna be IP, you should get IP kind of questions. But it's okay, I guess. No matter what, physics is still physics. Doesn't really matter, right? The only one that I think that wasn't really O level was that moments question. But this one, this toy here, this one here is definitely O level. Like that one is confirm O level. Like this one here is not O levels. I understand that. This water cooler pipe and all that also is O levels, but in a different form. This one is also O level. This one, yeah. But it is a selection of all the more difficult questions. You know, um, I mean, in case you're wondering, like what's your standard or anything like that. So he chose a very like a collection of harder questions. So it is a difficult paper. Like, what was the general feel of the other students? Like, around your class. Like, do you compare marks with them or anything like that? Mm, mm. But how about the results? Like your peers and all that. Did you like kind of like have a good sense of like where what's the benchmark at or anything like that? Okay. Mm-hmm. Okay. Okay. Yeah lah. I mean, that's what happens when you choose a like a slightly more difficult paper. But yeah, I mean, yeah, I'm just surprised. But okay, I'm like I said again, the like I'm not concerned about like the type of question he chose. I'm concerned on like the way you answer, right? I see the words that you use, I see the workings and all that. That's fine, right? Your teacher is very particular about you using formulas and all that. So next time, please put in the formulas, okay? But yeah, other than from that, please watch out for the careless mistakes, right? Okay lah. Then if nothing else, then I'll see you next year lah. No class lah. Your mom keeps asking me about whether you're gonna have class. So I was like, if there's no new topics, then there's no class. Yeah, right. I don't want to enforce lessons for the sake of enforcing it. So there's no point on. Next year starting, I think I'll do light already. Wait, have you done waves? Oh, then December I have to do waves because I did waves with the rest of them. Can ah? Are you going away anywhere? When? Which slot? Like when ah? I'm also gone for first 2 weeks of December. Yeah. Where are you going? Ah, okay. Okay. All right then. Going home lah. Okay. Um, can you drop me a message and tell me general waves in the last 2 weeks of December? Yeah. Can? Because I would need to cover that with you first before, because for the rest of them I already covered already. So I need to cover that with you first. Okay, text me, ah. Okay, that's all. That's all I have. Bye bye. Bye. All the best. Bye.